Hello everyone, my name is Ryan Tevis, and I'm going to do a geotechnical engineering example problem of the shown retaining wall and soil samples. As you can see here, the retaining wall shown is going to be an active retaining wall due to the fact that it is not rigid enough to resist the total forces of our soil sample, and so it's going to yield, and it's going to deflect just enough to cause it to be an active case. And so we use Ranking's active earth pressure, and so we're going to find K sub A, which equals tan squared of 45 minus phi over 2. And phi is going to be the angle that is given in the problem. And so to solve for this, K sub A equals tan squared of 45 minus 16 equals 29. And using my calculator, 0.307. And so this is going to be K sub A, 3.307. And K sub A is used as our coefficient that is applied to each one of our pressure diagrams that are due to each of the soil layers. So in the first sand layer, we have a gamma of 18, and so that's going to be our first pressure distribution, which at this point, we have gamma H, in which we need to solve for. Lastly, we can carry this pressure distribution all the way down. Otherwise, it would continue like this. But since there's a water table, we cannot continue the pressure diagram. So we're going to cut it off at this point and then just carry it straight down, being the uniform load that's being applied from the soil sample. Second, we have a uniform load that is being applied. So we draw our uniform soil block, uniform pressure block like this. Then next, we have the water table, and the pressure due to water is also going to be a triangular shape. And so at this point, it's going to be gamma WH. And then we have the sand, which is being saturated by the water table. And the sand that's saturated by the water table has a triangular pressure diagram. However, at this point, we use gamma B, which is the buoyant unit weight of the soil sample. And it is the saturated minus the water weight. And so, given these pressure diagrams, I can label them P1, P2, P3, P4, and P5. So these 5 pressure blocks are being applied to our active retaining wall. And so we're going to need to solve for what these pressure diagrams are, or what each one of these pressures are. And to do so, we find the area of each one of the diagrams. And so, looking at the first one, P1 and P2, we use our K sub A, and gamma H. So that's P1 and P2. However, we need to also apply the height, which is going to be our area, which I'll get to next. P3 is going to be K sub A cubed due to the uniform load. P4 is gamma WH, no K sub A, because K sub A is only applied to soil samples, not the water. And so lastly, we're going to apply K sub A, gamma B, and H. So now we have each one of our widths. And we're going to use the width multiplied by the height. Width times height equals pressure. So if I use this formula, P1 equals K sub A gamma H P2 is going to be K sub A gamma H. Now right here I have a little bit of a problem. Notice that P1 is a triangular shape, and so because of that, I must apply a 1/2 factor, and then P2 is applied to 2 different H's. We have the top and the bottom H. So which one of those do we want to use? Well, we can actually use both of them. We use H1 here an H2 right there. So we have the first height, which is given by this right here, and then the second height, which is given by this, like such. Now we have to go to P3, and that's our uniform load, and that is the K sub A cubed, and then times H1 and H2. Because in both, P4 is going to be the can of water, H2 times H2. Don't forget our 1/2. And P5 is going to be gamma B, which the buoyant weight needs to be calculated as gamma B gamma sat minus gamma W. And that's the buoyant unit weight. And so actually I'll use this equation times RKA and H2 times H2. And so now I have each one of the equations that I need to find the pressure and the area and the total pressure which is being applied to our retaining wall. And so if I plug in each one of these numbers and use my calculator to calculate it, I get P1 to equal 215.6. P2 is going to equal 44.2. P3 88.3. P4 78.5. And lastly, P5 is going to be 25. So since we're looking for the total pressure, pressure total equals the sum P1 dot 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 to P5. So it takes pressure 1 to pressure 5. And summing all of these up, I get a pressure total of 489.7 kilonewtons per meter squared. And there we go. I've solved with the total force that is being applied to this retaining wall due to the various soil layers and water table. And that is our answer. Thank you very much, and I hope you enjoyed watching this video.